In this study, we examined the neural mechanisms that might support the integration of talker information and phonetic detail during speech perception. A long-observed phenomenon in speech perception is that individual talkers may differ substantially in how they produce their speech sounds with regard to the underlying acoustics. For instance, the centroid frequencies that cue a sh for one talker might cue a s for another. Despite this variability, listeners are highly accurate in correctly identifying a talker's intended phoneme. Theoretical models suggest that listeners may leverage their implicit beliefs about how a particular talker produces their speech sounds in order to guide speech perception. That is, to know what a person is saying, it's useful to know who is doing the talking. We hypothesized that the right posterior temporal cortex might be particularly important for integrating these two sources of information. Neurobiological models of speech perception suggest some role for this region in phonetic processing, and the right temporal cortex is also known to be critical for processing talker information. In the current study, listeners heard two talkers, a female and a male, and we measured functional activation using fMRI. During an initial exposure phase, one talker produced an ambiguous fricative, a blend of s and sh, in s-biased context like episode, and the other produced the ambiguous fricative in sh-biased context like refreshing. During a subsequent test phase, listeners performed a phonetic categorization task for each talker with stimuli from a sign-shine continuum. Based on previous work using this lexically guided perceptual learning paradigm, we expected that their interpretation of the test stimuli would be shaped by the context in which they had previously encountered these ambiguous stimuli. However, we did not observe the expected perceptual learning effect. Though we expected a difference in the phonetic categorization curves as a function of previous exposure, the two phonetic categorization curves lay one nearly atop the other. Follow-up testing revealed that this lack of a learning effect was likely due to the headphones used in the scanner, which attenuated critical high-frequency auditory information. Nevertheless, we found that listeners showed differential phonetic categorization during the test phase as a function of talker, whether it was the female talker or the male talker. Thus, our data still afford an examination of the neural mechanisms of integrating talker information and phonetic detail. We just have to make the caveat that this talker information likely reflects acoustic or gender differences rather than lexically learned talker idiosyncrasies. To analyze the fMRI data, we first used a searchlight analysis to identify regions of the brain where the local pattern of activation contained information about who was talking. We used a parallel searchlight analysis to identify regions of the brain that contained information about what the talker was saying, specifically whether they said sign or shine. We found overlap between these maps in the right superior temporal sulcus, suggesting that the local patterns of activation in the right STS contained information both about who was talking and what was being said. Thus, the right STS may constitute an integration site for talker information and phonetic information. Finally, we conducted a functional connectivity analysis and found that during the phonetic categorization task, right hemisphere voxels that contained information about talker showed increased connectivity with left hemisphere regions implicated in phonetic processing, as well as right hemisphere regions implicated in talker processing. Taken together, our data suggest that the process of integrating talker information and phonetic information is achieved in two ways. It's supported by the activity of the right superior temporal sulcus specifically, and it's supported by the coordinated activity of a left lateralized phonetic processing system and a right lateralized talker processing system.